So we're going to be looking at, this is section 3.6, and we'll look at number 19 first. Okay? Number 19 says the following. The supply of a commodity in thousands of units, if the price is P dollars per unit, is given by the following equation. So the supply equation is given as 0.3 P plus 3. Now it says the demand for that same commodity, again in thousands of units, and I'll explain what that means in a minute, for thousands of units, is given as D equals negative 0.5 P plus 9. So we have a supply, we have a demand. In economics, we know that supply and demand indicate how much the customer wants and how much the actual manufacturer develops. So the supply is what they develop, and the demand is what you want. Now, before we even begin the problem, let's talk about this a little bit more. When you sell a product, and think about this in case when you get older, you go into business and you're looking at manufacturing. When you sell a product, what do you want? Do you want the supply and demand to be the same? Do you want it to be one greater than the other? How do you want it to look?
Equal.
Equal. Why equal?
Because if you want to have the same amount of stuff to equal the demand, so you can get out as much stuff and not be sold out so as much as you can.
Okay, one method. I agree with you. Now, in the beginning though, what do a lot of companies do? Can you close that window to the air, please? What do a lot of companies do in the beginning when they open their product?
Supply, so if the demand goes up, then they'll bring more supply.
Very good. And everybody knows, what's the new product that's coming out soon? iPad Mini. I guarantee you, they're already back ordered. They're going to have a supply of, say, 300,000, and they're going to have a demand of like 1 million. And what does that cause you to want? More. If you can't get the iPhone when it comes out, what do you want? You want to get it, right? So it causes customers to want and desire that product even more. Even more. So a lot of companies will have their supply lower than the demand at first. Eventually, they want to have the supply and demand the same so that A, they don't have too few of the product, and B, they don't have all the surplus at the end that they have to then liquidate or sell their assets for. So when the supply and the demand are equivalent, we call that the equilibrium price. Equilibrium. So, in this problem, it asks us three things. It says, graph both equations on the same coordinate plane, determine the equilibrium price, and then what will happen at prices greater than the equilibrium price. So let's do this. Brian, be careful, please. So if we want to graph these together, how can you graph these? Dan, give me a method of graphing these. What can I do?
When you use those intercepts and those slopes.
So you have the slopes and the y-intercepts, good. But I mean, like, as far as y and x goes, what is my graph going to look like? What's y, what's x?
It's another thing that like.
So you tell me.
I had price as the horizontal axis, and supply and demand in 100.
Very good. And what axis is that, though?
That's vertical.
Good. So when you're graphing this, and we're going to graph on the calculator in a minute, so I'm just sketching for now. You can use your graph paper if you like. Here, this is my y-axis, this is my x. This is like y1 here, this is y2. Again, y2 and y1. For the p value, this is like your x value in both cases. So what we're really graphing is this. The price along the horizontal axis and the supply and demand along the vertical axis. They are two separate linear functions. What possibilities might we have? What could these two lines do? There are three possibilities.
Mine, they want they cross.
Okay, so they can intersect.
And the intercept.
I said, what could they do? That's one. They can intersect. What else? They could be parallel to each other. The third one, Ryan? Overlap or coincide. Very good. The same line. If we are looking for an equilibrium price where they meet, there's a good chance that they will intersect. Okay? Make sense so far? All right. Now, we want to actually graph this, don't we? So let's go to our calculator. This is tough to graph initially, and these slopes are not very friendly. So I might want to use my calculator for this one. So let's go ahead and do so. Now, open our calculator.
Do you need a calculator? Ian?
Where's your calculator at?
In Y1, please put the supply function in Y1. In Y2, make sure you use the correct negative symbol. I'm highlighting it right now. Down here, not the minus sign. Negative 0.5x plus 9. Before we graph this, sorry. Who remembers, what did I say is the method that we're going to do to always start our graphing? What do you press to start? Zoom what? Standard, very good. Press zoom and then the number 6. Zoom 6 it.
You need to change your window though to get the exact thing.
Actually, no.
No.
If you have a standard zoom, you know. Yeah. You hit zoom 6, that means you made a mistake. You don't have an x in the second equation. It's the horizontal line, see that? Be careful with the equations, they gotta look the same as mine on the board here. Now, your y2, there goes, forget hands. So we want to find the intersection. Now, before I go any further though, let me think for a second. I can find the intersection right now, but if I were to graph this, can I have a negative price?
No.
So really, Hannah, go to window, please.
4.
Window, next to zoom, there it is. Make your x min 0, and then graph it, please. Because we really know that we can't have a negative x value, so this does help us zoom in a little bit. Now, we want the intersection, don't we? Before we do it, who remembers how to actually do it? Send me through the commands. Joe.
Second calc,
Second calc,
down to 5,
number 5 is intersect.
and then press enter.
Okay, hold on.
Yep.
Second calc is second, and then the trace button.
Okay.
Then hit the number 5. Then we have to guess on the first curve. So press the right arrow key until you get to the general vicinity of the intersection.
Wait, this is how I go here, right? Here,
Oh,
0.
Then once you press enter near the intersection, press it again on the second curve, then press it again under guess. The reason you are guessing or you're giving estimates is because what if there's more than one intersection? How does the calculator know which intersection you're looking for? So by moving over to the right, you're giving it an estimate of where the intersection is. Now, linear functions only intersect once. But if you have a parabola and a linear function, you can have multiple intersections. So this first curve, question mark, second curve, question mark, third guess, question mark, is just moving you over. Does that make sense? Yeah, just moving you over to guess. What's it?
Why does it want to take a guess?
Again, you're trying to find the general area of it, okay? You're picking up the first curve on the second curve, and then you're taking a guess in the local location so you can hone in on it.
Okay.
It's using the calculus technique of derivatives to actually find these locations. Sort of different. Doesn't really matter. Doesn't matter. Just as long as you're in the area of intersection. Again, first curve, second curve, guess. As long as the tick mark is in the area of the intersection, you will know where you're looking. Okay? So here's the question for you now. What's the answer? Joe.
7.5 next to 1.
So what's the answer, Joe?
What are we looking for here?
Supply and demand.
It said find the price at which the commodities will be in a state of equilibrium. What was the price? Which axis, guys?
The y axis.
Yeah, look over here. Please look over here. See a B on the x-axis? So what's our answer, everybody, now? Jerry? 7.5, and then we're going to talk about 1,000 in a minute, what that means. But 7.5 is the one we're looking for. The 5.25 doesn't really matter right now. That's the supply of the product and the demand of the product, but the price is what matters. So, we get P equals 7.5. But it said here, the in, let's see, in dollars. So this is $7.50. Well, how many units are we going to have in thousands of units in case that question was asked? What was our y at the intersection? What was our y value? 5.25. But it's 5.25 thousand because it says in parentheses in thousands of units. So your answer for the amount of units is 5.25 thousand, which we know is 5. Good. 5,250. Again, 5.25 thousand is 5,250. You know how I remember that? Because 5,000 is 5,000. So 5.25 thousand is 5,250. Okay, 5,000 and a quarter of a thousand. What is going to happen, part C? What will happen at prices greater than this price? So if I were to graph this again, or if I were to look at my graph here, my positive slope, whoops,
Sorry.
go back, Hannah, please. Thank you. My one with the positive slope here going up is my supply. So I've got this now. Supply is here. Demand is here. Before the equilibrium price, tell me what's going on. Physically, what's happening to this product and its sales? Before the equilibrium price.
At first, there's a really high demand, but not a high supply.
So this is like Guy Mini. Then what happens?
And then it keeps on going, and supply continues to reach the demand more and more.
Until it,
It actually does. And
Good.
then all of a sudden, there's more supply.
then there is. And what happens when there's more supply? What happens to prices? They go down. Okay, they go down. That's why when you wait a month or 2 months to buy a product afterward, you pay like 75% of the price of it. Especially things like phones, simply because they're coming out with new models all the time, right? You want to get the iPhone 4 or the iPhone 5, the 5 is more expensive than the 4. Because the 4, they have all this surplus. They want to get rid of it. That's why they have what are called factory stores. Factory stores, besides selling maybe sometimes cheaper products, they sell the surplus of those products. Okay?
It's sort of off topic. My mom's company is warehouse phones for Verizon and stuff.
Okay?
And I ordered my phone at the company today. It's the warehouse cell phones for Verizon.
Warehouse cell phones?
Yeah.
What does that mean exactly? Is that like the extra ones that they have that are
No,
not
it's
store?
like the actual cell, like the ones that are going to be shipped out. I'll get a phone shipped to me, like my iPhone got shipped to me from
From where?
the warehouse around company in
The
Texas.
shipping plan. It's just a place where it stores the specifically Verizon phone.
Yeah, say if you want to buy, say you ordered an iPhone 5 right now, it'd be shipped from there to you from that warehouse.
As opposed to coming from the store?
Yeah.
I got you. Sorry, I didn't know what the correlation was. I was trying to figure out this. You were just saying in general.
Yeah, because if you're talking about cell phones, it's
Okay, yeah. So yeah, sometimes they do that. That cuts out the middleman, so they have less cost. They don't have to transport it to the store and then send it to you.
And then it's like when you like with this the supply and remember what you were saying, like when I got my phone last December, it was either order from Verizon and it would take about 2 weeks, or I did the same because so many people wanted it for Christmas as a present, because it came out late October. They did like tell us what you want here and we'll have it ready for you at the store the next day.
So,
That's just like,
I'm just saying like it's supply and demand is up.
oh, I got you. Well, I just didn't understand. I'm trying to make a correlation here in this. So you're saying that if you wanted that product right away, you're able to tell them to pick it up in the store as opposed to waiting 2 weeks.
Yeah.
I got you. I got you.
that costs more
Do
too.
we get the idea of this though, guys? Again, initially it's a higher demand, then eventually the demand meets the supply, then the supply is surplus or it's above the demand, and you got these extra models. All right, let's look at the other problem that there was. Just get the right arrow key. The other problem said, this is number, unless we want to do a different problem. Was there another problem that stumped everybody in this class? The other class said 7 was the tough one, which is why I'm going over this one.
So it was like what we did during class.
It was, but something about trouble with it. Was there another one that was like being different?
13.
13, anybody get or have trouble with 13? Take a show of hands if you had trouble with 13. Be honest, obviously, guys. So those are hands going up. You all got 13?
It's because like it's the same thing as that. It's they don't give you the Y value, which is the original like speed. It's like what we did in class is a little bit different.
Let's try 13 because it's different. Just because it's different. 7 is very close to the one we did in class. The only reason people had trouble in the other class was because they forgot to use the right units. So if you have an hour and 40 minutes, how many minutes is that? 100. So you should use 100 as your method for your value of t. And your other t would be 120 because it's 20 minutes longer. Let's take a look at 13.
Oh, could you do that? And like I did it in hours.
You could. 1.66
and 2.
and then 2. Yep.
Okay.
1.66 repeating those.
Yeah.
As long as you have the same units.
Marshall flew her ultralight plane to a nearby town against a headwind. So is the wind helping her or not? No, it is not. So initially against the headwind of 15 kilometers per hour. So the wind speed, we know already, is 15 kilometers per hour. And it took her 2 hours and 20 minutes, which is, how many minutes? 140. Okay? Now, we want to find, or we're told we want to find the distance and we want to find the plane speed. We're told that the return trip under the same wind conditions took an hour and 24 minutes. So against and with. The wind speed is the same, so it carries over. But now the time is an hour and 24, which is 84 minutes. So far, so good? All right. The problem wants us to figure out how much of a distance there is between the two locations, and also what is the value of the plane's velocity or speed. So what's my general equation for these problems? What kind of problem is it? And what is my equation that I'm always using here? Ian? Yeah, D equals RT. Very good. Joe gave us that last class. D equals RT. Thank you, Ian. So, in the first condition, against the wind, if you're against the wind, what do you do to the speeds, Ian? And if you're with the wind, you add them. But I don't know what the speeds are. So let's make a let statement. Let x equal the speed of the plane. Let d equal the distance between the locations. So in the first case, I've got distance equals speed of the plane minus the headwind times the time period, which I'm going to leave blank for a minute. What was the headwind again? How much? What is it?
15 miles an hour.
15, thank you, kilometers per hour. On the way back, the distance is still d, right, because it's a return trip, but now you're with the wind. So how do I write this differently? What is it? Plus. Now, I want to write my times here. Here's time, here's time. But I got to be careful. I got to be real careful. Because I converted time to minutes, right? But what are my units of speed? Kilometers per hour. So either we got to change that to kilometers per minute, or change my minutes to hours. It's easy to change minutes to hours. If I have 60 minutes, how many hours is that? Because you just divide by 60, right? So take the amount of minutes you have and divide by 60 to give you a decimal. Well, 140 divided by 60 is 1.3 repeating. Oh, 2.3 repeating. Sorry. 2.3 repeating here. So this is 2.3 repeating hours.
That's what I did wrong.
84 minutes is 1.4. Exactly, right? So we have 2.3 and 1.4. I hate this board, guys. I don't know what to do.
Are you ever going to be able to use like your iPad and just project it on there?
Yeah, the wireless has been acting up. I tried to do it the other day in one of my classes, and it kept on like going in and out, so in the middle I had to stop and start over.
Yeah, it looks so much better when like that video on your iPad.
Oh, that's because I sit there at home and I write. Yeah, it's nice and smooth, right?
It doesn't like you're not like, oh, I hate this board, and then it's
I
just
know, it's all choppy and stuff.
I
know.
know.
Yeah, it's fine. I told Mr. Linus and
But
Mr.
you're
Richard they need
recording
to fix it.
it.
So, these are our two formulas here. Just to be careful to check, we have kilometers per hour, we have hours. Kilometers per hour, and we have hours. The hours are going to cancel. Numerator, denominator. Hours cancel. What am I left with? Everybody, what am I left with? Kilometers, and what am I solving for, really? Which should be in kilometers. So, I've got two equations and two variables. How can I solve? Come on, what methods? Okay, I can start by distributing. That's one way.
Usually to be able to divide because you have the distance as you already have your distance to be able to divide. But you can do that.
All right, so you can start by distributing that, and that's going to work. In addition, by the way, this is 2.3 repeating, sorry. In addition to that, aren't these both equal to D?
Yes.
So Joe, what could you do to them? Set them equal to each other. Very good.
Oh yeah.
I'll show you back there what you're saying. Good. So go ahead and do this. What does that eliminate? What variable is gone? D is gone. And what do we have only left, Chris? The x. So we can find the plane speed right here. Once we find the plane speed, we can plug it back into either one of these formulas to find the distance traveled. I'm going to leave this for you for the rest of it on your own. Okay? Again, distribute, please. Combine like terms. Solve for the value of x. All right, so what I want to do next is do an example where systems of equations come into play with everyday life. And everyday life for a math geek like me, maybe. Maybe not everybody.
3-6, right?
Say again?
This is still
Yeah, still 3-6. I just want to show you guys a cool example. Hannah, can you hand out? So we're going to talk about laser tag today. And the other class bugged me and said they want to go on a laser tag trip. I told them, I said, like, in a nice way, I was like, we can't take it here from school, but if there's a laser tag place that we all want to meet at, we can play laser tag, like, on the weekend or something like that. Maybe I'll try and get, like, another teacher to help.
like brown
You can come also. But I'll give you, know what I mean, I'll try and get, like, Miss Starks or somebody else, or one of the younger teachers that might want to come play some laser tag. You show them, things like that.
Yeah.
So I did it.
Like guys, it was crazy.
Mr. Lynch is probably want to come.
That's
Yeah.
a cool thing.
So we think out there, like Colton?
Not me. Mr. Tiotz.
All right.
No.
Now,
Miss Faber.
You got to stop. Okay, stop. That's really,
let's go to laser tag. So, some time ago, actually, can I get a person to read? How are you doing? Thank you. Okay.
Sometimes Mr. Howell was playing games of laser tag without his beloved students. After each game, the total team score and each player's score was shown on a scoreboard. In addition to this, each player received a printout of his/her individual performance. A sample of one of Mr. Howell's scorecards is seen below.
I like that you added these beloved students in the first sentence. So, this is a sample scorecard. Now, looking at this scorecard, you're going to see several things. Before I go into the actual question we're going to answer at the bottom there, let's look at the scorecard. They tell you, first, your score, each game. They tell you a lot of information, all the other players' scores and their scores throughout. But then they also give you input on here, which I think is important. They tell you all about your shots fired, accuracy, all that stuff. But then they say, you shot somebody, and there are sensors. You have a front sensor, which is on your chest. You have a shoulder sensor, and there's 4 of them. One on each shoulder, front, back, back. Then there's a back sensor, which is right in the middle of your back. and then there's a phaser, which is your gun, the sensor on your gun. So you can shoot somebody in 4 different methods. Now, in addition to that, you can shoot the base, which is called bases tagged. You can sit there and shoot it, and then if you're the last person to shoot the base and it actually blows up, that's considered destroying the base. So there are 6 ways to gain points for your team. So far, so good? All right. Now, this is a true story. I'm not messing with you guys at all. We finished the game, and I'm pretty much reading the bottom paragraph. We finished the game, and one of my friends said, you know, I wonder what it's worth to shoot somebody in the chest versus the back versus the shoulder, or is it really worth shooting the base? What do we get for it? Because we didn't know. So we went up to the guy at the desk and said, like, hey, what does each thing worth? And he's like, I have no idea. So we're sitting there, and I'm like, wait, we can figure this out. It's not tough. No? So everybody's like, what do you mean? I'm like, well, really, we have 6 variables here. We have 4 locations you can shoot somebody, and then you can shoot the base in 2 different ways, right? So I said, all right, so if we have 6 variables, everybody, how many equations do everybody need? 6. So this was not enough. This one scorecard told me 1 equation. And what you can do is, you can think of shooting in the front as X, Y, Z, W, call this A, call that B, and you could say, like, for example, I shot, so this is me, this was my scorecard. I shot somebody 19, or the other team 19 times in the front. So I have 19 times however much each front shot is worth. Then I shot them in the shoulders 33 times. And so forth and so on, totaling, so dot, 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 adding all these up, totaling 11,050. Okay, 11,050. I did in this game. I actually got the best score in this game.
Where are you?
Can you just walk in there and then shoot each person?
They don't tell you the score every time you do it. If you literally, you would lose the game though if you specifically had to shoot something in the chest every time.
No, say if you guys were just went in there and shot someone and then just sat there for the rest of the game.
It's a waste of money. So I wouldn't do that. It's a waste of time. I wanted to know and I had to solve it, so I said, you know what? Screw it, I'm going to solve it this way. So, here's the score at the top, 11,050. Now, that would give me 1 equation. How do I go? Thank you. I can do this. I got the command over here. So, for this problem, we have 6 variables. Front shot, shoulder shot, back shot, phaser shot, tagging the base, destroying the base. Now, my 1 equation that I already stated is right here. That's the equation I just wrote on the board. So what I did was this. I grabbed my scorecard from the last game. I grabbed 2 of my friend's scorecards from his first 2 games, another 2 from another friend. So we had my 2 games, somebody else's 2 games, another 2 games, and we wrote 6 equations out. And what you're going to see are all 6 equations here now. Here's all 6 equations. The first one is right here. And after that, you don't have to write them down, guys. It's just to learn after what we're talking about. Here are the other 5 equations. Okay? And clearly, you think this is the game actually that I did the best right here. That was my score. And notice what I did. Look at this game. This game, I stopped shooting the base in the other one, and I'll explain that in a minute. So,
You didn't shoot the base in all, it's 0.
no, this one was, the first one was here. This is my scorecard right here.
Oh, no.
Yeah. All right, so anyway, with 6 variables and 6 equations, how can I solve this? What can I do? Joe?
They're all lined up. They're all variables in the equation.
Yeah, I can tell you're doing that already, right? Nice. So, write yourself a matrix. Here's a question for you. What will the dimensions of that matrix be? Jared?
6 by 7.
Very good. Well done. 6 rows, 7 columns. 1, 2, 3, 4, 5, 6, 7 columns. So it's always RC, rows by columns. So it's a 6 by 7 matrix. Joe, did you plug it in yet? You almost there? It takes a while, right? Yes. It's an organizational system of writing linear equations. It also has to do with 3-dimensional movement when you start to study computer movement. If you look at like 3-dimensional graphic design, and you want to think about how they show animations moving, it's all matrices that show rotation and movements. 3x plus 2 equals 3, 2, 7. That would be a 1 by 3 vector. It's called a matrix.
How do you write it down?
Bracket, 3, 2, 7, close bracket.
Yeah.
Yep. It's only one row. So here's what we got.
Yeah.
You want to wait for me, John? Let me know where you're at.
How do you even know the last of the matrix?
All right, I'll wait for you then.
Okay.
How do I know what, Nick? Daniel?
How do you remember the out of the matrix that you previously had?
How do you get rid of what's in it? Just right over it. Go to the dimensions of it. Top, just type over it. You can always type over your matrix that's in there.
Okay.
19.
Here, guys, let me just put the organized matrix here. Make it easier. Is that better to see?
Yeah, what do you do? You
I don't want to give the answer yet.
Okay.
Second quick, go back into the matrix, over to math, down to RREF.
Is it 6 by 7?
It is 6 by 7, yes. Rows by columns, rows by columns.
How long did it take you to do this?
When I was at laser tag, you know what I did actually? I pulled out my phone and I looked up online on a matrix calculator. And I just used that matrix calculator. Probably took me about, I don't know, 3 or 4 minutes. Right? I mean, once you do it, it's pretty easy actually. It's not that tough.
I mean,
All
like,
your
your
friends
friends
were
were like,
What did this say?
One of them's actually, so one of them that was there, oh, we have a bunch of teachers. Me and a few teachers went to play. So, yeah, my last school, we had a very young staff. Like, I was actually older than a good amount of the teachers did.
oh, that's.
I know, right? Think about it. There were a lot of teachers that were just out of college.
Was it a newer school?
It's been around for about 4 or 5 years, so it's newer for sure, yeah.
Okay.
So anyway, I was with a bunch of teachers. One of them was a social studies teacher, but he's really good at math. So he knew what I was doing right away. He's like, oh, it's a system of equations. But the other ones didn't really know. How we doing? Those that are working, almost done?
I got my stuff, so I just stopped.
Let me know what you got when you're ready, and I'll take a look to see if you're ready.
Oh, it's sorry.
And by the way, your answers will be integer values, and they will be multiples of 50. So like numbers like 100, 200, 150. Those are the answers you will get for this. Once you enter the whole matrix, press second quit again, quit out of it, then go back into the matrix, then go over to math, then go down to RREF. Make sure it's RREF. Hit enter, then go back to the matrix, and just enter again. And then we're done. Yep. And it is. Those are your answers. Good job, Kate. So again, your answers will be multiples of 50. By the way, let me give you guys a little tip. When you enter things into the matrix of the calculator, do the first row first. Because every time you enter on the matrix, it moves left to right. So enter in rows, please. Enter 19, then 33, then 17, okay? Don't enter down, enter across, please. The whole matrix? Quit out.
I didn't get it.
So it's probably not yet, it's quite a tight one. After REF, go back into the matrix, and just press enter on matrix A. Not edit, but underneath. Okay, now go back in. And then just enter on A. Here's a mistake, or my mistake. Write the equations for each row, see what they are. Move over, press the right arrow key and see the numbers fully. Anybody want to check the answers?
Wait, can you tell us the answer outside?
Oh, yeah.
Just want to make sure she said some of that stuff and stop.
All right. Here is our reduced matrix, everybody. Now, what I would like you to do is to also please think about what it means. This is really the x variable. Y, Z, W, A, V, and then my right, the first row now, it would be 1x plus 0y plus 0z plus 0w plus 0a plus 0b equals 200. So the y, z, w, a, and b aren't even in the problem here. They're not even in the equation. So it's pretty much 1x equals 200, or just x equals 200.
Wait, so one thing doesn't have anything with the tagging?
Yeah, that's the thing I noticed, and that's what I was going to talk about. So hold on one second.
So tagging it, the space, doesn't do anything.
No. So this was the shoulders worth 50 points. The back is worth 100 points, and so forth and so on. So let's make sense of our answers now. Let's make sense of our answers. Daniel already mentioned, tagging the base gets you nothing. So you can sit there and shoot the base all day, but somebody on your team needs to destroy the base to actually get points. Now, the other thing was this, and this is what annoyed me. You can destroy the base, and then afterward you can sit there and tag it, but you can't destroy it again. So people would destroy the base, and then stay at the base and try and destroy it again. But they wouldn't get any points for it, because tagging the base doesn't get you anything. So now we knew, once you destroyed it once, you're done, right? Don't go to the base anymore. And we have that strategy on our team now. Also, notice, why is the front worth the most points? Jared?
Because it's hardest to hit the front.
Yeah, because if the person's looking at you, are they going to shoot you back? As opposed to what?
Back.
The back. It's only worth 100.
You need 2 shoulders.
What? In the shoulders, there are 4 actually. There's 4 sensors. There's 2 in the front and 2 in the back on the shoulders. So those are worth nothing. Why is the gun worth so little? This was the one that nobody was able to get. There's a reason for this. I think if you guys play Halo or Call of Duty and stuff, why would the gun be worth so little?
They're just sticking the gun out and shooting at people with the bases.
Yes, exactly. If you're like, imagine you're crouching here, right? And Joe's coming around the corner. I'm going to do this, right? So what's exposed? My gun. My body's not exposed, so your gun is traditionally going to hit faster. Let's think about this. The gun should have the most shots. The gun had the most shots of 38. The shoulders should